I'm going to teach you a class on property of operations. The class will consist of several things. First, before we get into property of operations, we need to know what operations are we talking about. So what I tried to do was I tried to break it down for you really cool, where you'll get a lot out of it. And this is really something that you'll take from not just sixth grade math, but all the way through high school. So if you can get it now, you'll be good for high school. You'll be better than good, matter of fact. So I passed out to everybody, should have with them a little pink piece of paper with them. We're gonna fold it sort of like hamburger style. Hamburger style, fold it square, like that, close it in half for me first. Put a little crease in it. It don't have to be automatic, just close it up. And then fold it again for me where we got 4 halves. So when you fold it, it should be a little square, something like this right here. All right, so fold it again. You got halfway. Fold it one more time for me, sir. Isaiah, can you fold it one more time? Okay, so when we open it up, we ought to have 4 halves where we have 1, 2, 3, and 4. 4 halves. We're gonna write something on each one of these halves. This is something for you to keep for yourself, so whenever you forget maybe or what's going on, you can go back and result back to this and it's to help you. That's it, sir. You got it. So the first one we're going to talk about is called the commutative property. If you look up here on the top here,
Go ahead and write that on
you go ahead and write that commutative property. Put it in one of your squares. Just number that square as number 1 and put commutative property. C-U-M-M-U-T-A-T-I-V-E. This word right here.
Perla. Genesis. Your pink paper. Write that in one of your squares.
Right here, commutative property. Okay? Give you a second or two seconds to write that down for me. Commutative. When you think of commutative property,
Got it, Isaiah?
think of the word commute. Means commute gets you back and forth, right? So some of us rides the bus to school, right? Right. If we ride the bus to school, the bus has to go down the road here. It has to come back up the road. Commute means you're going back and forth. So the same thing here. What we got here is in a good example here. We said Dad commutes to and from work by a bus or train. I got in a picture of a train, I think it is. So the train goes both ways. It can go down the road and it comes back. Or a bus goes down the road, it comes back. Think of the word commute. That word right there, commute. So when we think about it in math, math is a little easier. We're saying in addition, in the word addition, we have 4 plus 5 equal 9, correct? So if we switched it, if we said 5 plus 9, that means we went down the road the first way on the 4, we went that way to get 9. Now to come back to get 9, we're going to say 5 plus 4 equals 9. Does it not? Yes or no?
that. Yeah.
Okay, same thing. So if we said 4 plus 5 equals 9, when you come back the other way in the commutative property of addition, you can say 5 plus 4 equals 9. Is that right? So right there, really easy. Put that example in there of a commutative property.
Use any numbers you want to.
Any numbers you want.
Use any numbers you want to.
If you're adding them, they should all come up the same. So when we go into commutative property, another good example would be to say the numbers being added can be changed, which we changed the 4 and the 5, and the outcome will still be the same. That's in addition, commutative property. In multiplication, same
4 plus
thing.
8. 8 plus 4.
if we say 2 times 5 equal 10, can we say 5 times 2 equals 10?
Good, Marie.
Anybody? We can't? Yes, we can. So if we say 2 times 5 equals 10, help me out. I'll go over here. 2 times 5 equals 10. Does 5 times 2 equal 10?
Yes.
Yes. That's the multiplication side of it. We just went with the 2 first that way and a 5 first that way. Same thing to get to the same result, 10. Okay? All right, so I think we got the commute a little bit. So in your first block, I want you to have me an example. 4 plus 5 equal 9, and 5 plus 4 equal 9 on the addition side of the house. And then any number plus itself, any number can be changed, and the outcome would still be the same. So we can flip-flop the numbers any way we want. The outcome will still come the same. Okay? Now let me ask a question. Will it work for subtraction? Let's erase this and see will it work for subtraction.
14. There you go. Now do it for multiplication.
So, anybody want to take a stab for that? I got a reward for you. Anybody want to take a stab for that? Will it work for subtraction? Go ahead, sir.
I think it will.
You think it will? Okay, let's try it. So let's say
You think it will too?
3 minus 2 equal what?
1.
1, right? Okay, so if we say 2 minus 3, what does that equal?
0.
No. What?
I was gonna say
Negative 1. Exactly, sir. Negative 1. Is this the same as that? No. So it does not work for subtraction. Good, sir. I'm going to get you a treat. Get one.
It does not work.
It does not work for subtraction.
B or B plus 3 minus 2.
Yes, exactly. Because 3 minus 2 is 1, but 2 minus, which is a negative 3, is a negative 1. That does not work. So it does not work for subtraction. Now let me ask one more question because I think you guys are pretty sharp. I'm glad I came in here, matter of fact. Does it work for division? Divide. Say we had this number.
yes, it does.
You said yes? Well, let's see.
Think
Let's
about
see.
it.
3
Think about it.
divided by 9 equals what?
Like, I would even say before they get to the answer.
Wait.
Continue. Keep going.
It can't work for division because 9 divided by 3 is what? 3. 3 divided by 9, that's a decimal.
It's like 1/3.
Yeah, it's not the same. It does not work for subtraction and division. The commutative property does not work for subtraction and division. Make sure you remember that. All right, let's get that off of there. And like I said, you guys are pretty good. Let's go to the next one. So in your one box, you ought to have this example right here for me. Everybody got it? Okay, let's go to the next thing. Next thing we want to talk about, let's say identity. Identity property. Let's cover these up because we don't need them. Identity property. Identity property of addition and multiplication. Write that example in for me. Something to remember with identity property of multiplication is any number that can be added to a number without changing its value. Any number that can be added to a number without changing its value. So, here we say this number here, 3. We added that number. 3 plus 0 equals what?
3.
3. Thank you, sir. So if we say 3 times 1, what's 3 times 1, Genesis? 3 times 1, what's this number? 3, exactly.
Good
Make
job.
sure I reward you for that, Genesis. Good job.
Very good.
So, in identity property of addition, any number added cannot change its outcome. It'll still be the same. We have two more properties that we want to get to you, and we tried to show you here in identity, you got a mirror. When you look in a mirror, you see yourself.